In this video, I will show you how you can detect and recognize faces in an image. For additional code samples and instructions, please refer to Learning Open CV5 Computer Vision with Python 4th edition book. And you can have a look at samples in the GitHub repository mentioned here. First of all, we need to install the dependencies OpenCV contrib Python. Then to run the following script, which provides a compatibility layer between OpenCV and Google Colab. We imported OpenCV and we replaced some of the OpenCV's I/O functions with our own functions that do not rely on a windowed environment or on a local file system. For example, first of all, we replaced the CV image show. Because Google Colab notebooks don't support GUI windows, so we mentioned this function which mimics CV2 image show but works in notebooks. Then to replace the CV2 wait key, this function waits for keyboard input, GUI based. This doesn't work in notebooks. So this is our function to return immediately to prevent notebook from freezing. And here we overrided the original function. Then to replace the CV2 image read. Image may not exist locally. Notebooks often rely on remote files. So we downloaded the image from GitHub, go there and then download it, then save it in your environment, on your Google Drive environment. Then you can perform the face detection on a still image. This to have access to the Google Drive, and then to use this file that you downloaded from GitHub repo and stored it in any place in your Google Drive. Just you have to mention the path, click here, and then you can click and copy path and paste it here. Then when you run the code, you can see that the code have no false positive detections. All three rectangles really are woodcutters' faces. However, we do have two false negatives, woodcutters whose faces were not detected. Try to play with the parameter of detect multi-scale, this one and this one, which 1.08 means that scale 8%. And the lower, you will notice maybe you will get more accurate result. And this means that min neighbors, which is the lower, maybe get you to more accurate result. In future video, I will explain more about face recognition with more complex algorithms.